last one we're going to do is holmium. Named after Patrick Mahomes because he's such a great quarterback. They knew years ago that he was going to be around being the greatest quarterback we've ever seen. Maybe not. I don't know. I don't get the feeling that scientists and sports don't always mix. Except in this case. Anyway, holmium is element number 67 down here. It's in the F area. Okay? So, it's element number 67. So we're going to start off what we did before. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. Now we go through all 10 of the 4ds, 4d10, back up to the 5th level p's, 5p6, and then 6s2. And this is where things get a little bit sketchy. And it's that stinking gap we got here. Now remember, some of you don't have that gap. Some of you already have lanthanum in there. But you got to be careful and look at the numbers carefully. Lanthanum is element number 57. That makes sense because it follows 56, so there you go. But the next one on that chart is 72. So that means that we can't go from lanthanum to hafnium. We have to jump down to our F's right here. Well, remember, holmium is in this first row of F's. Now, since these two right here belong up here, we ignore them and we'll focus only on the cerium through lutetium in this first row. Well, we don't even have to go as far as lutetium because we're going to holmium. Now, these are F's. And the thing about F's, even though this is found in the 6th row with the cesium and barium and the lanthanum, these are 2 rows late because they were supposed to appear for the first time in the 4th level. So that means that these are 4 F's. How many 4Fs do we have? Well, let's count them. Cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, and holmium. That is a total of 10. So that's 4F10 go up to 67. So our electron configuration turns out to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d1, that's your lanthanum, that's your only D, 5d1, and I need to emphasize that when we go to barium to lanthanum, that is the D in the 5th level. So 6s2, 5d1, and then the 4 F10s, which is what we end up with. All right, one more. Electron configuration for platinum. So now we're going to be going to element number 78. So this is where we got to, again, be kind of careful here when we get down to this area right here. So you got to watch for that. So here's, we'll go through real quickly what we did before. And after you do this enough times, you can actually do this look at the periodic chart. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6. Okay, now I'm showing off and then on and on from that. Now you might have noticed something kind of changed there when I did that. Let's take a look. Platinum, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Now, here's where things get tricky. You got the 1d right there. Then we go past the next 14 Fs. Those are the 4F and then 14 of them. And then we come back to the Ds. Now these Ds, from hafnium to platinum, fill in well after the first 5D shows up. And because of that, we add this one to the rest over here and proclaim that they are higher energy electrons than the Fs, including the lanthanum. the reason for that is because the D's and the F's just change around like crazy for reasons that we're not really going to get into, but it's a matter of stability for the atoms to fill up half the shells, half the paths, orbitals, but it's a little complicated. But what we are going to do is we're going to automatically say that this is going to be 6s2, and then we're going to add this to these over here, so we're going to put the 4f14 down next, and then count the D's, 1, 2, 3, 4, 5, 6, 7, 8, after the lutetium here. So that gives us 8 of the, let's see, that's 5d electrons, 5d8. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d8. And so it should look something like this. Right? Just the way I said. Again, double check to make sure it works out right, which I did here, and we get 78, and sure enough, platinum is element number 78. So you can double check your work in that way. It doesn't guarantee you have a right answer, it'll just guarantee that you have the right exponents on the right number of electrons traveling in those particular orbitals. Your practice problem. Find the electron configuration for each of these 5 elements. Okay? Good luck.